Imagine a metal so rare and valuable that it can be 12 times the price of gold. Believe it or not, this ultra expensive element might be hiding in plain sight in your car's exhaust. Why are thieves scrambling on their cars to get it? What makes rhodium so special that industries can't do without it? Today we will explore the captivating story of rhodium, the element that you chose in the poll. From its discovery with a rosy surprise, to its extraordinary properties, its crucial modern uses, and the reason it has become the most expensive element on the Earth. Welcome to Cube Chemistry, where we will discuss all the elements of the periodic system and also do experiments. So if you like this video and want to see more, make sure to like, subscribe and hit the notification bell so you will never have to miss another episode. Also, if you fill in the poll, you can influence what experiment we will be doing next week. So inside this cube is a shiny metal. Now, if this disc inside would be fully rhodium, I probably could not afford it, since rhodium is about $1,000 per gram. This is a silver disc plated with rhodium, which is fine because we can't look on the inside anyway. Now it seems very reflective, and I wonder if one of the properties of rhodium is its reflectiveness. I'm also wondering whether it is conductive. Now, the way that it is presented is different from the other metals, and I love the look of it. Now, if you want your own disc of plated rhodium, make sure to click on the link in the description and use the promo code so you will get a 10% discount and you will be helping out our channel. Now, the story of rhodium begins in the early 19th century, at the time when the world was enthralled by new elemental discoveries. In 1803, an English chemist named William Hyde Wollaston was investigating ores of platinum, the fashionable new metal of the era. Now, platinum ore from South America was known to contain impurities, and Wollaston had already struck gold, so to speak, by isolating a new element, palladium, from this ore. But there was more hidden treasure in that unassuming rock. Now, legend has it that fellow chemist Hippolyte Collet Descotil noticed something odd. Solutions of platinum ore sometimes turned a beautiful red color. This hinted that another unknown substance was present. Intrigued, Wollaston decided to dig deeper. Now he devised a methodical experiment. First, he dissolved the platinum ore in aqua regia, a potent mix of nitric and hydrochloric acid capable of dissolving noble metals. Then he removed the platinum itself by precipitating it out as ammonium chloroplatinate, a solid compound of platinum. Other metals like copper, lead, and recently discovered palladium were also stripped away. What remained was a mysterious solution that didn't match any known element. Through careful chemical steps, neutralizing acids, adding zinc, filtering, and precipitation, Wollaston finally obtained a deep rosé red powder. When he treated this powder with zinc, it yielded a small amount of a new metal, rhodium. Now the name rhodium comes from the Greek word rhodon, meaning rosé, inspired by those rosé-colored chemical salts that revealed its presence. It was a brilliant christening for a shiny new element. In the span of a year, Wollaston had discovered two new elements, palladium and rhodium. 1803 was certainly a good year for him. Little did he know that one of them, rhodium, would someday become the priciest metal in the world. Now, what exactly had Wollaston discovered? Rhodium turned out to be quite a remarkable element. If you held a piece of pure rhodium in your hand, not that most people ever get to do that, but well, we got it in a cube, you see a silvery white metallic shine that rivals chrome. So in fact, rhodium is extremely reflective. Polish it up and it gleams like a mirror. This metal is also hard and tough. On the Mohs hardness scale, rhodium is around a 6, so that means that it's harder than pure platinum or gold. It is not very malleable, meaning it doesn't bend or shape easily, which is also a hint at its strength. Now, one of rhodium's defining traits is its resistance to corrosion and tarnish. It belongs to the family of noble metals, along with platinum, gold, and a few others, which are noted for their reluctance to react with most chemicals. Rhodium takes this to an extreme. It practically refuses to oxidize or rust. Now, you could heat rhodium in air and it won't even form an oxide coating, as most metals do. It stays shiny. Only at red-hot molten temperatures will it temporarily absorb oxygen, but it spits it right back out upon cooling. Now what about acids? Well, ordinary acids like hydrochloric acid and sulfuric acid don't phase rhodium at all. Even nitric acid, which aggressively dissolves many metals, gets nowhere with rhodium. The only thing that can dissolve rhodium is aqua regia, and even that does so only slowly and grudgingly. Now, this incredible chemical inertness is part of what makes rhodium so valuable for certain uses. It can endure harsh environments where other metals would corrode away. Let's dive a little bit deeper into the chemistry, because it's pretty interesting and relevant. Aqua regia is so good at dissolving metals for two big reasons. First, to dissolve a metal, you need to remove electrons from its atoms. With non-precious metal, that's easy. H+ ions from any ordinary acids can do the job. After all, an acid is just something that releases H+ ions when it dissolves in water. That is why metals like iron and zinc can dissolve in regular acids. But precious metals like gold and platinum hold on to their electrons much more tightly. Hydrogen ions alone can't pull them away. Instead, you need something much stronger, an oxidizing agent. And that's where nitric acid comes in. Oxidizing means stealing electrons, and nitric acid is very good at that. It contains N5+ ions, which have been stripped away of a lot of electrons and are desperate to grab some back. When nitric acid reacts, it grabs electrons and turns it into nitrous acid. The second reason why aqua regia is so powerful has to do with the chloride ions from hydrochloric acid. When a noble metal like gold is oxidized by nitric acid, it forms Au3+ ions. These Au3+ ions immediately combine with Cl- ions to make gold chloride complexes like AuCl4-. This is important because it locks away the gold ions, preventing the reaction from reversing itself. In other words, the system never reaches a stable balance, so the metal keeps on dissolving. Now, rhodium is also notable for its high melting point and stability at heat. It melts at about 1964 degrees Celsius, that would be 3567 degrees Fahrenheit, nearly as hot as an active volcano's lava. Such a high melting point means rhodium can withstand extreme temperatures without melting or warping, which is a big advantage in high heat applications. Its density is somewhat lower than platinum. Rhodium is heavy, about 12.4 grams per cubic centimeter, roughly 50% heavier than silver, but not as ultra-dense as platinum or gold. So in hand it would feel hefty, but not insanely heavy for a metal. However, the same toughness contributes to a downside. Rhodium is difficult to fabricate. It's hard to cast or shape because of that very high melting point and because it is not very bendable. This is one reason why you don't see, say, pure rhodium jewelry sold in stores. It's too stubborn a metal to craft easily and, as we will see, far too expensive to use in bulk. Instead, rhodium is often used in protective coating or specialized forms where its durability is key. For many years after 1803, rhodium didn't have much of a job. Then slowly people found niches where this rare metal could shine. One early use came around the turn of the 20th century: rhodium-platinum thermocouples. Now, a thermocouple is a sensor for measuring temperature, often made of two different metals. By alloying a bit of rhodium with platinum, scientists created thermocouples that could measure extremely high temperatures, exceeding 1700 degrees Celsius reliably. Rhodium's high melting point and stability meant these devices could poke into furnaces and still give accurate readings without melting. A first taste of rhodium's industrial potential. Next, rhodium found its way into the world of decorative coatings. Jewelers and metalworkers discovered that a thin plating of rhodium on jewelry, or silverware, gave a fantastic brilliant white shine and prevented tarnish. Around the mid-20th century, rhodium electroplating became popular for luxury goods. White gold jewelry, which is basically gold alloy mixed with white metals, is almost always plated with a whisper-thin layer of rhodium to make it look extra bright and resist scratches. That gorgeous reflective look on a new white gold ring, thank rhodium for it. Over time, the rhodium can wear off, which is why an older ring might look a little bit dull until it is replated. Sterling silver items are also sometimes rhodium plated so they don't tarnish and turn dark. Because rhodium stays untarnished, a coating of it keeps silver shining like new. Now, an absolute game changer for rhodium arrived in the 1970s and 80s. Automobile catalytic converters. If you have a gasoline-powered car built in the last few decades, it's almost certain to have a catalytic converter in the exhaust system. And inside that device, there is a small but crucial amount of rhodium at work. Now, why is it there? It comes down to cleaning up the exhaust pollutants. Car engines produce some nasty byproducts: carbon monoxide, unburned hydrocarbons, basically fuel, and nitrogen oxides. Catalytic converters are like chemical scrubbers that use precious metals as a catalyst to convert these toxic emissions into safer gases before they leave the tailpipe. Platinum and palladium in these converters handle carbon monoxide and hydrocarbons by turning them into carbon dioxide and water. But nitrogen oxides, which cause smog and acid rain, require a different approach. They need to be broken apart into nitrogen and oxygen. This is where rhodium is the hero. Rhodium is exceptionally good at facilitating the reaction that takes nitrogen oxide pollutants and converts them into plain nitrogen gas, which makes up most of our air. Now, the introduction of the three-way catalytic converter, so-called because it handles three major pollutant types, in 1976 by Volvo, marked the moment rhodium went from obscurity to industrial stardom. All of a sudden, car manufacturers around the world needed rhodium to meet new environmental regulations. Each catalytic converter only uses a few grams of rhodium at most, but when you multiply that by hundreds of millions of vehicles, it adds up pretty fast. Today, around 80% of all rhodium produced is gobbled up by the auto industry for this very purpose. In a sense, rhodium has been saving millions of lives and lungs by helping reduce air pollution from vehicles. Cars might be the biggest use, but they are not the only modern domain where rhodium shines. In the chemical industry, rhodium-based catalysts are a big deal too, albeit behind the scenes. One famous application was the Monsanto process for making acetic acid, the main component of vinegar, which was developed in the 1960s. This process used a rhodium complex as a catalyst to efficiently turn methanol into acetic acid on an industrial scale. It was so effective that it dominated the acetic acid production for decades, though newer methods using iridium have since taken over to some extent. Rhodium catalysts are also key players in hydroformylation, a reaction that transforms simple olefins, alkenes, into aldehydes, which are then used to make things like plastic, detergents, and fragrances. Originally cheaper metals like cobalt were used for this, but rhodium proved far more efficient, so much so that despite the cost it became the standard. Now let's talk a little bit more about catalysis. That's when metals help reaction happen faster or more easily. Some metals can break apart gases like hydrogen and oxygen right on their surface. Normally, splitting molecules like H2 takes a lot of energy, and it can only happen at very high temperatures. But on the surface of special metals, H2 can split into individual hydrogen atoms even at room temperature. Once you have these free hydrogen atoms sitting on the surface, they can easily react with other molecules. Without the metal surface, breaking apart H2 would create unstable, high-energy free atoms, which is very difficult. Metals lower that energy barrier by giving the atoms a temporary landing path. Now, it seems that rhodium can do something similar. It can bind oxygen atoms temporarily and reversibly on its surface. And that is one of the reasons rhodium is so incredibly good at catalysis. Now, if you think about it, some of the household products that you use, the plastic in your container, the scent in your soap, might owe their existence to rhodium catalysts that help synthesize one of its ingredients. Now, rhodium's brilliant reflectivity and durability under heat have made it useful for optical instruments and mirrors. For example, high-performance searchlights and film projectors in the past sometimes used rhodium-coated mirrors because the metal could handle intense light and heat without dulling. Some telescope mirrors or scientific instrument mirrors have been coated with rhodium for the same reasons, maximizing reflection while minimizing corrosion. In modern cars, rhodium is even used to coat headlight reflectors for a long-lasting shiny finish. Then there are electrical and electronic uses. Rhodium doesn't oxidize and has a low electrical resistance, which is a perfect combo for electrical contacts. Tiny amounts of rhodium are plated onto switch contacts, connectors, and electrodes in various high reliability electronics, so they don't corrode or build up resistance over time. Now, for instance, the spark plugs of some aircraft engines or high-end cars might use a platinum rhodium alloy tip to ensure they last under intense conditions. Now, one special interesting high-tech use of rhodium is in nuclear reactors. Certain nuclear reactors deploy rhodium-based sensors inside the reactor core to monitor neutron flux, essentially the intensity of the nuclear chain reaction. Rhodium has a unique response to absorbing neutrons. It transmutates in a predictable way, which can be measured to deduce the reactor's activity. Moreover, rhodium can withstand the extreme environment inside a reactor core, such as radiation, heat, and corrosive conditions, without degrading quickly. So, rhodium plays a quiet role in helping keep nuclear reactors safe by providing critical data from deep within the reactor core where few other materials could survive for so long. Finally, rhodium even finds its use in the medical field. One surprising application is in pacemakers and other implantable medical devices. These devices often use platinum or other noble metals for their electrodes and components. But rhodium plating is sometimes applied to electrical contacts or leads. Why? Because inside the human body you need materials that will not corrode or cause reaction over many years. Rhodium's stability and conductivity ensures that pacemakers' conditions stay reliable for a long time. Now, a little cultural footnote, rhodium has even been used to celebrate human achievements. In 1979, the Guinness Book of World Records presented Paul McCartney, one of the Beatles, with a special award disc for being the best-selling songwriter of all time. And that disc was plated with pure rhodium. Now, why am I saying this? Well, I'm a big Paul McCartney fan. Now, by now you might be thinking, alright, rhodium is useful and pretty cool, but what makes it the most expensive element? And the answer boils down to the word rarity. Well, rarity combined with indispensability. Rhodium is exceedingly rare in the Earth's crust. It's often cited that on average, rhodium is about 0.0002 parts per million of the crust. Now, that number is so small, it's hard to imagine. Think of it like this. For every billion atoms in the Earth's crust, not even a couple might be rhodium atoms. It's like looking for a few specific grains of sand on a miles-long beach. Even compared to other rare elements, rhodium is exceptional. It's rarer than gold, rarer than platinum, rarer than almost all the natural occurring elements we mine. Not only is it scarce, but nature doesn't clump rhodium into convenient deposits for us. There are no rhodium-rich veins of ore that miners can directly target. Instead, rhodium is typically found mixed with other metals. The only way to get it is to process huge amounts of ore from mines that are actually after something else. The majority of the world's rhodium comes as a byproduct from platinum and palladium mining, particularly from South Africa. South Africa alone produces around 80% of the world's rhodium in some years, thanks to its large platinum mines. In those mines, for every ounce of platinum pulled out, there might be only a few milligrams of rhodium tagged along. In other places, like the nickel mines of Sudbury, Canada, trace amounts of rhodium are extracted during the refining of nickel and copper. It's painstaking. Imagine mining and refining an entire truckload of ore and ending up with a tiny speck of rhodium. That's the reality. The annual worldwide production of rhodium is in the order of 30 tons or less. To put that into perspective, gold's annual production is about 3,000 tons, which is about 100 times more. And even platinum, another very rare metal, sees around 200 tons mined per year, which still dwarfs rhodium's output. All the rhodium mined in a whole year could theoretically fit in a couple of large crates. Now, couple that minuscule supply with a high demand, especially from the auto industry and the industrial sectors we've discussed, but because the market is so small, it doesn't take much to upset the balance. Now, when an ounce of metal is worth more than a brand new car, it's bound to attract thieves and opportunists. Indeed, a wave of catalytic converter thefts struck many countries during the price surge. Thieves would saw off the converters from parked cars to extract the rhodium, alongside with the palladium and the platinum. inside and sell them to scrap dealers. Now, this meant that many car owners woke up to the loud roar from their engine and a hefty repair bill. And this was basically a telltale sign that the catalytic converter was gone. This is a direct consequence of rhodium's rarity and value in the modern world. Now, since that peak, rhodium prices have come down substantially. As of now, they are a fraction of the 2021 high, though still several times the price of gold. Now, this retreat happened as supply caught up a bit and the demand leveled off, and perhaps as the market anticipated the rise of electric vehicles which don't use catalytic converters. But make no mistake, rhodium is still extremely expensive. We're talking thousands of dollars per ounce, even in normal times. It consistently trades as one of the priciest elements because there is just never enough of it to go around. Another reason why it stays expensive is that extracting and refining rhodium is laborious and costly. Think of the chemical process Wollaston went through to isolate rhodium. Modern methods are obviously more efficient, but it remains complex. Refineries have to dissolve tons of materials, separate multiple precious metals via intricate chemical steps, and finally isolate the tiny fraction that is rhodium. And that is not cheap. Also, because rhodium's market is small, it's not traded on big public commodity exchanges the way gold or oil are. It's often sold through specialized dealer. This can lead to somewhat illiquid market where prices jump around with small shifts in trading. All these factors together explain why rhodium commands such a high price. It's the classic case of something that's incredibly rare and incredibly useful. A recipe for being valued like a king. In fact, rhodium's nickname would well be the king of precious metals. So next time you hear about precious metals, think beyond gold and platinum. Remember rhodium, the metal that rose from obscurity with a rosy glow and can be found in simple things like a wedding ring or car parts. Rhodium is both a scientist's metal and an engineer's metal, prized in labs and factories. Yet most people don't even know it exists, but now you do. Now, if you're really into noble metals, make sure you watch this episode about silver. Now, if you think I missed anything, let me know in the comments, and if you like this video, make sure to like, subscribe, and hit the notification bell so you will never have to miss another episode.